Have you ever taken a look at the open source networking landscape and just felt completely overwhelmed? I mean, you open up the Linux Foundation networking page and you're hit with this wall of projects. ONAP, Anuket, Sylva, Nephio, the list just goes on and on. It can be incredibly difficult to figure out where to even begin, what each project does, and most importantly, how they're all supposed to fit together. If that sounds familiar, then believe me, you have come to exactly the right place. Welcome. In this special deep dive explainer, we're going to methodically unpack this entire ecosystem. Our mission today is to build a clear, solid mental model, piece by piece. We're not just going to list what each tool does, we're going to explore the why behind them. Why were they created? What specific problem do they solve? And then we'll zoom in on one project in particular, Nephio, which is truly changing the game for how we think about telecom and cloud automation. My promise to you is that by the end of this session, you will have a solid, cohesive understanding of how all these powerful and sometimes confusing tools can work together in harmony. All right, let's get started. So here is our roadmap for this journey. We've structured this explainer very intentionally, and I want to spend a moment on it so you know what to expect. Think of it like a funnel. We're going to begin at the widest part, in Section 1, with a high-level view of the entire landscape. We're calling this a Toolbox of Solutions, and it's where we'll get familiar with all the major players. Then, as we move through the sections, the funnel is going to narrow. We'll focus our attention squarely on our main subject, Nephio. In Section 2, we'll introduce it as the unifying force. In Section 3, we'll dissect its framework to see how it works under the hood, and in Section 4, we'll talk about its real-world impact. After that deep dive, our funnel will start to widen again. In Section 5, we'll zoom back out to see how Nephio, combined with all the other tools from our toolbox, orchestrates a complete end-to-end solution in the real world. And finally, in Section 6, we'll look to the future. It's a journey that takes us from the big picture down into the critical details of a key technology and then back out to see how it all connects to build something bigger than the sum of its parts. It's a comprehensive approach, but it's the best way to truly understand this complex world. Okay, let's dive right into our first section, a toolbox of solutions. You know, one of the biggest paradoxes in networking today is that the core problem isn't a lack of options, it's an absolute explosion of them. The open source community is just buzzing with innovation, which is fantastic. But let's be honest, it's also genuinely confusing to navigate. The absolute best mental model I've found for this is to think of it all as a giant shared toolbox. Now, if you're working on a project at home, you wouldn't use a sledgehammer for every single job, would you? Of course not. You need different tools for different tasks. You need wrenches for plumbing, screwdrivers for electrical work, saws for carpentry. Each tool is designed and optimized for a very specific purpose. The exact same principle applies to open source networking. There is no single magical project that solves every problem from end to end. The real art, the real skill for a network architect today is knowing which tool to pull out of the box for which job, and this is the crucial part, knowing how to combine them effectively to build something truly powerful. And that simple toolbox analogy brings us directly to the two questions that drive network architects and developers absolutely crazy. First, with all these options, which tool should I even use? And the immediate follow-up is, okay, once I've picked a few, how on earth do they work together? It is so easy to look at this landscape, see 5 different projects that all have cloud-native orchestration in their description, and just assume they're all competing to do the exact same thing. But that's a surface-level view. The reality is so much more nuanced and, frankly, more interesting. Each project was born out of a specific need, a specific gap in the ecosystem. Each one has a different sweet spot, a different job it was engineered to do exceptionally well. The real power, the magic of this open source model, isn't unlocked by trying to pick one project to be the ultimate winner. It's unlocked when you realize you can combine several of these specialized projects to achieve a single complex business goal. So really taking the time to understand what each tool excels at isn't just an academic exercise, it is the absolute key to building anything effective and scalable in modern networking. So let's open that toolbox. Here's a look at the major tools we're going to be discussing. Now, don't feel like you need to memorize every single name and acronym right this second. That's not the goal here. The goal is to start building a mental map, to understand the different categories of tools we have at our disposal. We have tools for orchestration, tools for defining architecture, tools for providing working code, tools for exposing APIs, and so on. We're going to take a moment to introduce each of these, one by one,
to understand the specific role they play in this very busy, very innovative landscape. First up, let's talk about a big one, ONAP. That stands for the Open Networking Automation Project. And the story of ONAP is really a story of evolution. When it first launched, its ambition was absolutely massive. It aimed to be the single, all-encompassing platform that would handle every aspect of network automation. But over time, the community wisely recognized that a monolithic approach can be inflexible. So ONAP evolved. It transformed into a powerful, modular set of tools. This is key. Now, instead of having to adopt the whole thing, organizations can pick and choose the specific ONAP components they need for a particular job. Maybe they just need its best-in-class service design capabilities, or maybe they want to use its components for closed-loop automation, which is the incredible concept where the network can detect a problem and heal itself without human intervention. Its real superpower, though, is its deep alignment with industry standards bodies like ETSI and ORAN. This makes ONAP the perfect bridge between the modern, cloud-native world and the existing business and operational systems, the so-called OSS/BSS, that run the core of every telecommunications company. Next up, let's look at Anuket. To really get what Anuket is all about, you have to know its origin story. It was actually born from the merger of two earlier, very important projects. One was called OPNFE, and its job was to create a reference architecture, a kind of blueprint for how to build a telecom cloud. The other project was called CNTI, and it was focused on gathering and documenting what network service providers actually needed from those clouds. Anuket brings these two critical missions together. So think of Anuket as the definitive, operator-approved set of blueprints for building a telecom-grade cloud. It takes that long list of business and technical requirements from operators all over the world and distills it into a standardized architectural model that everyone in the industry, both operators and vendors, can build towards. It provides a common language and a common target. Now this is where it gets really interesting. If Anuket provides the detailed architectural blueprints for the house, the next project, Sylva, comes along and actually builds a working model home that you can see, touch, and even move into. Sylva provides a reference implementation, and this is a huge, huge deal. Anuket is the what, the plan. Sylva is the how, the actual code. It takes those Anuket blueprints and builds a fully operational, cloud-native infrastructure. This is incredibly valuable for operators who don't want to start from scratch. It gives them a practical, powerful, and pre-validated starting point that is not only agile and resilient, but is also specifically designed to comply with the very strict data sovereignty and security regulations that are common in the European telecom world. It's theory put into practice. Okay, let's shift gears a bit. We've talked about building the infrastructure. Now let's talk about how to actually make money from it. And that is exactly where CAMARA comes in. CAMARA's entire mission is to bridge the gap between the incredibly powerful capabilities of modern 5G networks and the world of application developers. See, developers don't want to learn the intricacies of network engineering. They just want simple, easy-to-use APIs to make their apps better. CAMARA's job is to create those simple, abstract APIs. A perfect example is a service like Quality on Demand. Imagine a mobile gaming company. With a CAMARA API, their app could make a single, simple call to the network saying, hey, this user is in a critical part of the game, give them a super fast, low-latency connection for the next 10 minutes. CAMARA makes that possible, turning network functions into monetizable services. In that same world of simplifying complexity with APIs, we find Paraglider, but it's aimed at a slightly different audience. While CAMARA is for application developers wanting to access network capabilities, Paraglider is for the cloud users and operators who have to manage the underlying connectivity. In today's world, it's totally normal for a single application to have components running in multiple places. Some on Amazon Web Services, some in Microsoft Azure, some in a private on-premise cloud. Connecting all of that together securely and efficiently is an absolute nightmare of virtual private clouds, complex routing tables, and security groups. Paraglider's goal is to make all that plumbing invisible. It wants to give you a simple API where you can just state your intent. I need this web server to be able to talk to that database, and Paraglide figures out all the complex networking required to make that happen, securely across any combination of clouds. Now for a project whose importance cannot be overstated, CNTI, the Cloud Native Telecom Initiative. Its job is to accelerate the entire industry's transition to cloud-native technologies. It does this in two main ways. First, it establishes and promotes best practices. But second, and perhaps more importantly, it runs a vendor-neutral testing and conformance program for what are called cloud-native network functions, or CNFs. Think of a CNF as a piece of network equipment, like a router or a 5G core, that has been rewritten as modern software. CNTI acts as a kind of independent quality inspector. When a vendor claims their product is cloud-native, CNTI provides an objective, standardized test to actually prove it. This is vital. It gives operators the confidence that the different pieces of their network from different vendors can actually work together dynamically in an automated environment. Let's move down the stack a little bit, to the software running on the physical network switches themselves. Here we have two major players, Sonic and Dent. Sonic was born inside Microsoft's massive Azure cloud, forged in the fires of hyperscale networking. It's famous for its revolutionary approach. It took the old monolithic software that used to run on switches and broke it down into modern, independent, containerized microservices. This was a game changer because it completely decouples the switch hardware from the switch software, preventing vendor lock-in. Dent, on the other hand, is focused on a slightly different space. It aims to create a standardized network operating system, or NOS, built directly on the standard Linux kernel, specifically for white box hardware at the network edge. Think of simplifying the networking for thousands of retail stores or remote enterprise branches. That's Dent's sweet spot. And finally, let's quickly touch on some of the foundational engines that power many of these other systems. We have OpenDaylight, a true veteran in this space. It's a highly modular and flexible platform for implementing software-defined networking, or SDN, where you centralize the control and intelligence of the network. Then there's OVS and OVN, Open vSwitch and Open Virtual Networking. These are fundamental tools for creating and managing virtual networks inside your servers, the plumbing that connects all your virtual machines and containers. And then you have the absolute speed demons, the data plane accelerators, like DPDK and FDDiOS VPP. These are highly specialized software libraries that allow applications to bypass the normal slower pathways in the operating system's kernel and process network packets at unbelievable line rate speeds. They are the high-octane fuel that makes modern high-performance, software-based networking possible.
Okay, take a breath. We have just surveyed that entire crowded and incredibly innovative toolbox. Now, as I promised at the beginning, our conceptual funnel is going to begin to narrow. We're going to shift our focus from the broad landscape to one specific project. The project that was designed from the ground up to be the unifying catalyst for all of this inherent complexity, Nephio. Its core purpose, its reason for being, is to bridge the huge gap that exists between the elegant simplicity of the cloud-native world and the massive, bespoke complexity of traditional telecommunications networks. A key thing to understand is that Nephio doesn't try to replace all those other tools we just talked about. It provides a unifying automation layer on top of them. And to really truly get what makes Nephio so special and so different, we need to spend some serious time understanding two core ideas that are its absolute unshakable foundation. And this first idea, this first pillar of Nephio, is a complete and total game changer. It's the philosophical shift from imperative to declarative automation. Let's really break this down. Think of it like this. The old imperative way is like giving someone turn-by-turn directions to get to your house. You write out a long script, turn left on Main Street, drive 2 miles, turn right on Elm, go through 3 stoplights. It's incredibly detailed and it's incredibly brittle. If one of those roads is closed for construction, the entire script fails. The person is lost. That's how traditional automation scripts work. Now, contrast that with the declarative approach. Declarative is simply giving someone your address and telling your GPS, take me home. You declare the desired end state. You don't specify the how. The system, the GPS, is smart enough to figure out the best route. And not just once. If it encounters traffic, a detour, an accident, it will actively reroute to make sure you still get to your destination. This is the magic of Kubernetes, and by extension, the magic of Nephio. You declare what you want. I need a 5G user plane function with this capacity connected to this core at this site, and the system not only figures out the hundreds of steps to make that happen initially, it then constantly watches and works to keep it that way. This concept of active reconciliation is the heart of declarative automation. The second foundational pillar, which is just as important as the first, is the principle of configuration as data. This sounds a bit academic, but its practical implications are profound. It means you treat all of your network and service configuration files with the exact same rigor and discipline that professional software development teams treat their source code. What does that mean in practice? It means your configurations live in a version control system, like Git. Every single change, no matter how small, even changing a single IP address, has to be proposed, reviewed by a peer, approved, and then merged. It's not just some file that an engineer edits on a live system in the middle of the night. Why is this so incredibly huge? Imagine a network update goes wrong at 3 a.m. The old way is a frantic, high-stress scramble, with engineers trying to manually undo changes and figure out what went wrong. The configuration is data way. You simply revert the last change in Git. You click a button. The system, which is always watching that Git repository, sees the change and automatically restores the entire system to its last known good state. It gives you a complete, unchangeable audit trail of who changed what, when, and why. It gives you perfect repeatability and,
Most importantly, a critical safety net for managing complex, mission-critical systems. This is the very heart of the GitOps operational model that Nephio is built upon.
So, we've firmly established Nephio's core philosophy. Its two guiding stars: declarative automation and configuration as data. We understand the what and the why. Now let's get practical. How does Nephio actually do it? How does it turn that powerful philosophy into working, running code that can manage a global network? In this section, we're going to pop the hood. We're going to take a look at the Nephio framework's architecture, dissect its core components, and understand the key open source tools it uses to bring this entire vision to life. This is where we move from theory to implementation. At its most fundamental level, Nephio's architecture makes one incredibly and strategic choice. Instead of trying to reinvent the wheel by building a brand new orchestration engine from scratch, it leverages the most successful and widely adopted automation engine on the planet: Kubernetes. Nephio uses Kubernetes itself as its universal automation control plane. This is unbelievably powerful. It means the same battle-tested, resilient, declarative engine that the world's biggest companies use to manage their stateless web applications can now be used to manage stateful, complex network functions, and even the cloud infrastructure that runs underneath them. It provides a single, consistent API for everything. Now, on top of that Kubernetes foundation, Nephio adds its own specialized secret sauce: the declarative automation framework. This framework, which is also built on Kubernetes principles, gives you the specific tools you need to manage all those complex network configurations as clean, reusable, version-controlled data packages. It's the telco-grade specialization built on a cloud-native foundation. That declarative automation framework relies on a trio of key open-source tools that work together in a beautiful, logical flow. First, we have Caped. Caped, which is pronounced kept, is a tool that lets you bundle a whole collection of different Kubernetes and configuration files into a single, neat, versionable, and reusable module. Think of it like this. Deploying a network function might require 50 different YAML files for deployments, services, config maps, and so on. Caped lets you package all of that up into a single, cohesive unit. It's like having a standardized Lego block that represents an entire complex network function. This ability to abstract away complexity into manageable, reusable packages is the first step toward taming the beast. Now, if Caped gives you the individual Lego blocks, the next tool, Porch, acts as the central library and management system for all of those blocks. Porch is a package orchestration server. It's a central API endpoint where teams can publish, discover, and consume their Cape packages. It's much more than just a simple registry, though. Porch provides critical enterprise features like versioning, so you can have version 1.0 and 1.1 of your firewall package. It provides access control, so only authorized teams can approve a package for production use. And it provides a full audit trail, so in a large organization, everyone knows exactly which version of a configuration is approved for deployment and who made the last set of changes. It's a governance layer for configuration as data. And finally, we have the third tool, ConfigSync. This is the engine that closes the loop and makes the entire GitOps workflow a practical reality. ConfigSync is the crucial link between your library of packages managed by Porch and your live network infrastructure. It's a small software agent that you run inside your Kubernetes clusters, and its only job is to constantly watch your central Git repository. The moment an approved change is committed and merged into the main branch of that repository, ConfigSync sees it, automatically pulls the new configuration, and applies it to the cluster. If there's any drift, if someone makes a manual change on the cluster, ConfigSync will detect it and revert it. It is the tireless robot that ensures your live network always matches the desired state defined in Git, eliminating manual error-prone deployment processes.
So we've gone deep into the technology. We've dissected the architecture, we understand the components, Kipt, Porch, ConfigSync. But here's the most important question. So what? Why does any of this really matter in the real world? In this section, we're going to shift our focus from the technical how to the business why. We'll explore the real-world impact of adopting a framework like Nephio, how it addresses deeply rooted industry problems, and how its effects go far beyond just the technology, fundamentally changing the people, the culture, and the business itself.
To really appreciate Nephio's impact, you first have to understand the core, underlying conflict it was specifically designed to solve. It's a tension that has defined the telecom industry for decades. On one side, you have the traditional network equipment vendors. For perfectly understandable business reasons, they often create automation systems that are closed, proprietary, and tightly coupled to their own hardware and software. This can lead to vendor lock-in, making it difficult and expensive for a service provider to switch or to integrate equipment from multiple vendors. It also often creates a reliance on expensive professional services contracts for any change or upgrade. On the other side of this tension, you have the network operators, the telcos. They have a strong desire to take control of their own destiny, to build their own automation capabilities, and to move faster. But they face a very steep learning curve after years, even decades, of relying on those vendors to manage the complexity for them. Nephio steps directly into the middle of this long-standing friction with a new, open approach.
This quote from the source material absolutely nails it. The impact of adopting Nephio is profoundly twofold, and you can't have one without the other. The first impact, and I would argue it's the most important and most lasting one, is the cultural and mindset shift. By championing open, common, community-driven tools that are based on the industry standard of Kubernetes, Nephio pushes organizations to change the way they think. It encourages them to invest in their own people, to build in-house automation skills, and to break free from the dependency on proprietary black box systems. It fosters a DevOps and a site reliability engineering mindset of ownership, collaboration, and continuous improvement. And that fundamental cultural change then leads directly and inevitably to the second impact, the tangible business impact. When you own and control your own automation stack, the business benefits are immediate and compounding. You reduce operational costs by moving away from expensive custom tools and service agreements. You gain fine-grained, granular control over the ongoing day-two operations of your network, things like upgrades, scaling, and security patching. And most importantly, by creating this agile, automated foundation, you create the capability to innovate and to launch new services for your customers much, much faster than your competitors. Speed to market becomes a core competency.
And here's what's truly fascinating. While Nephio's DNA comes from the world of telecommunications, the core principles it's built on, declarative automation, configuration as data, management via a Kubernetes control plane, are universally applicable. At its heart, Nephio is simply a superior framework for managing any complex, distributed, multi-cloud application. Take the explosion in artificial intelligence in machine learning, for instance. Deploying AI training and inference models across a hybrid cloud environment and efficiently managing scarce, expensive resources like GPUs and TPUs is a massive operational headache for enterprises today. This is a perfect use case for Nephio. Its declarative, package-based approach is ideally suited for orchestrating these kinds of complex, resource-intensive enterprise workloads, proving that its value extends far, far beyond just traditional networking. This brings us to the narrative climax of our entire explainer. This is the moment where it all comes together. We've surveyed the entire toolbox of solutions. We've done a deep dive on Nephio, dissecting its philosophy and its architecture. We've talked about its cultural and business impact. Now, let's see how it all works in concert. We are going to walk through, step by step, a complete end-to-end example of delivering a real-world service, quality on demand. This is where we'll see how all the different open-source projects we discussed at the beginning can work together in perfect harmony, each playing its specialized part, with Nephio acting as the crucial automation catalyst at the center.
But before we begin that walkthrough, it is absolutely critical to highlight what Nephio doesn't do. And this isn't a weakness, it's a strategic design choice that represents its greatest strength. Nephio intentionally leaves higher-level concerns like end-to-end service orchestration across multiple domains or direct integration with billing and customer management systems, the OSS/BSS, out of its core scope. This is a feature, not a flaw. By maintaining a laser-like focus on its primary goal, automating the complete lifecycle of network functions and their underlying infrastructure, it avoids becoming a bloated, overly complex monolith. It is designed to do its one job exceptionally well, and to provide clean, standard APIs to plug in with other specialized tools, like the modules from ONAP, that are designed to handle those higher-level business and service orchestration tasks. It's the philosophy of do one thing and do it well.
Okay, let's walk through this quality on-demand scenario step by logical step. Step 1 begins long before we build anything. It starts with CNTI. The network operator uses the CNTI conformance testing framework to rigorously verify that the cloud-native network functions they've purchased from their vendors are actually cloud-native. Do they adhere to best practices? Can they be configured dynamically? Can they be automated effectively? This is a vital quality control check at the very beginning of the process. All right, our parts have been verified and have passed inspection. We can move to step 2, building the foundation.
Leveraging the Anuket architectural blueprints for the design and the Sylva reference implementation for the actual code, the operator's platform team builds out the standardized, consistent cloud infrastructure they need. And they build it everywhere, across their edge locations, their private core data centers, and even into the public cloud. This ensures they have a consistent, resilient, and trusted base to run all their services on. The foundation is built and ready. Now what happens? In step 3, a business request comes in. A new enterprise customer is signed up for a premium, low-latency service. A higher-level orchestrator, like ONAP, receives this request from the business systems. Its job is to translate this business need into a technical service plan. It figures out all the pieces that need to be put in place. For the specific part of that plan that involves deploying and configuring the software on the cloud platform, it knows the right tool for the job. It makes an API call and triggers Nephio to do its work. And this brings us to step 4, the moment where Nephio takes center stage. This is its absolute sweet spot. Receiving the trigger from ONAP, Nephio gets to work. It fetches the correct pre-approved CAFT packages for the required network functions from the Porch server. It then hydrates these generic templates with all the specific details for this particular customer, like their IP addresses, VLAN tags, and site information. It then pushes the final configuration to the Git repository. ConfigSync picks it up and deploys it to the correct clusters. And most importantly, Nephio's job isn't done. It now manages the entire life cycle, day 0, day 1, and day 2 of those functions, constantly ensuring the live network state matches the desired state defined in Git. The service is now provisioned and live on the network, but how do applications actually use it? That's where we get to step 5, CAMARA. CAMARA exposes the complex network capability that Nephio just provisioned as a simple, clean, developer-friendly API. Now a video conferencing application or a cloud gaming platform can make a single, easy API call to request guaranteed low latency for a specific user session, without needing to know anything about the mind-boggling complexity of the 5G network that Nephio just orchestrated underneath. It's the bridge to the application ecosystem. And finally, step 6. Let's close the loop. What happens if there's a problem and the customer calls the support center? The support agent needs a complete picture of all the service components, which might be scattered across multiple private and public clouds. This is where Paraglider comes in. It provides that unified, abstracted view of connectivity, allowing the customer care systems and troubleshooting tools to see all the data they need, regardless of where the components are physically running. Every tool playing its specific, specialized part, working in concert to deliver one seamless end-to-end service.
We've seen how all these intricate pieces fit together to build solutions today. For our final section, let's cast our gaze forward and look to the horizon. This entire ecosystem of declarative automation and open-source collaboration isn't a final destination. It's a foundation. It's the launchpad for even more powerful and intelligent capabilities. So, let's take a few moments to explore the key emerging trends that will continue to shape the exciting future of network orchestration. So, what's next on the frontier? The powerful, data-rich foundation we've just discussed enables some truly exciting future trends. First and foremost, the rise of AI and machine learning in network operations. With highly structured configuration data in Git and real-time telemetry from the network, we can move beyond reactive management. We can use AI to analyze this data to predict network congestion or hardware failures before they even happen and automatically take preventative action. This is the promise of proactive, predictive network management. Second, the full transition to true cloud-native technology will only accelerate, unlocking even more flexible, scalable, and efficient network architectures. And finally, the sheer growth of the network itself. More 5G users, more IoT devices, more fiber to the home, means the demand for this kind of smart, scalable automation isn't just a nice-to-have anymore. It becomes an absolute, undeniable necessity to manage the scale and complexity of it all.
And this really brings us to the single most important takeaway from our entire discussion, which this quote from the source material captures perfectly. The fact that there are so many of these open-source projects, which can seem confusing at first, isn't a weakness of the ecosystem. It is its greatest strength. This vibrant, sometimes competitive, diversity is precisely what drives innovation forward. It allows organizations to avoid one-size-fits-all solutions and instead assemble the exact right set of tools they need to meet their unique business challenges. The toolbox is rich and varied for a reason, and that's a very, very good thing for the entire industry. So, we'll end our journey with this final, provocative question for you to consider. For so long, for decades really, the primary struggle in networking has been operational. The focus of our best engineers has been on answering the questions, how do we deploy this? How do we configure it? How do we upgrade it safely? How do we just make it work and keep it working?
the powerful declarative automation paradigm that we've talked about at length today promises a future where making it work becomes the reliable, automated, and frankly, boring default. So the question for all of us in this field becomes, what happens then? When our time, our energy, and our creativity are finally freed from that constant operational toil, how will we shift our collective focus? How do we move from just maintaining the network to truly innovating on top of it? As automation finally takes care of the how, we, the humans, get the incredible freedom to dream up the what's next. And that, perhaps, is the most exciting future of all. Thank you for joining me for this deep dive explainer.